All right. Hi, everyone. My name is Stacy Véronneau. I'm going to do a little talk today on faking bare metal lab using public cloud resources. Basically, a quick intro. The agenda is going to be fast, but so quick intro, challenges, solution, and a demo time. Talking about faking bare metal needs to actually have a real demo. It takes some time to run, so of course I won't tempt the demo gods like they did this morning and try to spin something that takes some time within 12 minutes, so that won't happen. So quick intro, who am I? Montreal-based, working for CloudOps. 21 years of IT experience. Lead the OpenStack architect for CloudOps. Also do some work with Marentis. The bear is not coming. So for those who, OpenStack history so far for me, exposure starting at Folsom, some Ericsson Montreal experience getting, the beauty of working there is that they have access to resources. And then from now on the CloudOps at Marentis, then just you stop counting from customer to customer and analysis from analysis. Just a quick plug for CloudOps itself. We're 100% Canadian, so we are partner for Citrix, Marentis, AWS. But the important part is why. What was my challenge? Like everybody, you can run an OpenStack lab in VirtualBox or VMware Workstation on your laptop, and it works. You can use Marentis OpenStack, you can use Ubuntu using Bash and Juju, and it will work. But at one point, I need more resources, and my laptop is about to explode. So the other thing is that I don't want to go to my CEO and say, well, I need 4 racks just when I want to do some tests, and after that, it's just gonna just run the electric bill, and that's it. So I need something that's more flexible. What I want to be able to run a lab that can scale. I can go to AWS, GCE, Azure. They have resources, but if I just go to AWS and I spin on some region a small instance, I'm going to take something from their catalog. What I want to do is fake bare metal. So if I take a mass or Marentis OpenStack approach, the entire cycle starts from a node discovery from a Pixie boot somewhere. Like I have Cobbler running, so I need a discovery. So I can do that with AWS with what they're offering. Like I said, I want a lab that behaves like bare metal. I want pass-through, so I can just run QEMU, but I want KVM really all the way down. I want layer 2 control, so I can have VLANs for tenant isolation. And I want a pay-per-use model. That's the business side of things that kicks in because my boss say, well, I won't give you 50K for your lab, but I won't let you just go run crazy without having any idea of what you're going to do. So basically cost prediction. I found a solution. And so basically 15 months ago, the Google logo just went way right. That's PowerPoint from PC to Mac. That gives me VT all the way down, layer 2 control. I can import disk image. I can use the ipxc.iso to fake the boot cycle. I can save blueprints, so I can replay them, and I have a pay-per-use, and cloud-based. Yeah, so hence the Kool-Aid guy. I want to be quick disclaimer here. This is not a sales pitch, so sorry, Vince, for the Ishamwa. That won't happen. For me, this is a means to an end. So the solution that's there, it's a third-party solution that's online. It was a startup. They've been bought by a bigger company. Good for them. But it's actually to show you what can be done to achieve that need of having a bare metal lab that can scale, so that you can do more than just spinning 4 VMs, having some fun and testing, but actually do something at scale. So. The company in question is, it was Ravello. One of the guys from Ravello Systems was actually the guy who wrote KVM, so they kind of know what they're doing. They did it so well that they got purchased, which is good for them. Like we said, the proof is in the pudding, so I'm just going to kick a little demo here, and I will follow along. Just give me 2 seconds. All right. So this is the Véronneau interface, but basically the idea, I'm just going to pause it. The idea goes around, you create an app. It could be like, oh, let's call it OpenStack. This one I've called it vBrownbag rocks because it is. So you get a blueprint. I'm using, well, you have multiple images you can use. MongoDB, stuff that's already pre-canned and pre-configured for you to use. In my case, I just want an empty node. And to validate the Pixie part, which is the important part for discovery, just for this small demo, it's just 2 nodes. So I have 2 nodes. I can define, well, I can give them a name, like MOS 8 for Mirantis OpenStack. I can give it a host name. I can give it value for CPUs. I can go up to 8 vCPUs, 24 gigs of RAM. You can give it a timeout. Then you define, storage values and so on. I'm just gonna. You can attach an ISO, so I've uploaded my ISO there. ISOs are stored in S3 buckets, so your cost is super low. So that's a good savior. Like any bare metal machine, before anything, I'm really configuring them a layer 2. So I'm giving them an IP and everything without any OpenStack there. Right now, this one's going to be for OpenStack. Basically, you can use this for anything that you need to fake bare metal. So I'm just going to give it a little kick because we're on the timer here. So the idea, again, I'm prepping resources. I'm sorry, just want to regular beer. There's the ipixc.iso there. It's just 800K or 700K that allows you to have that discovery that's going to happen. And this is online. It's free. You just pick it up. You upload it. It's there. You can use it. Important part is the networking part. Basically, this one is Mirantis OpenStack. So while this is running, I'm just going to talk over it. Mirantis OpenStack for the fuel node or the MOS node need at least 2 NICs. So one for public access, like you want to go to UI, fuel itself. The other one is for the admin network, which is the discovery. That's where it happens. The other node on this one is going to be like, let's call it just a raw OpenStack node I want to do. And I'm just going to give it 2 NICs. It doesn't make sense for production, but the intent of this is not production. It's for a lab. So my first NIC is going to be on that Pixie network, and the other one is going to be, let's aggregate all the roles from OpenStack and put it on a single 1 gig, and that won't happen because it's going to be an issue. So once everything is set up, right now you can see you have a layout of what your network can look like. So you can see that the MOS 8 node here has 2 NICs. One is on the 10.30.0 network. That's the Pixie part. And the other one is 10.20, which is the public one, which is actually, and now move this guy here. You can see that actually this one has a router, so basically I have outside access. The other NIC, it's the Pixie part for node 1. The node 1 has two NICs. One is on the 1030, the other one on 1020. So basically right now what I have is just 2 nodes, nothing on it, no OS. So of course something needs to happen. So we're just gonna just before I do that, just wanna show you just tying up to cost control. When you publish, you can define, cost or performance. So depending if you want it to be cheap or fast, so then you can select AWS or GCE, and then the zone you want to be in. So that's really useful, maybe for some lab you want to do, but that's on a specific AWS zone. So when everything is ready, your instances or your wrappers are published, and the ISO that was attached to it actually is going to pick up. So my fuel node is actually booting fuel. So nothing, astonishing or fancy so far. But if I go on the other one, that's the iPixie part. Nothing's happening. So Go fast forward, the entire Marentis OpenStack thing is installed, so that's all good. And then the I got my 2 minutes count. So then after that, the other node just pixie boots once fuel is done, and then you have full discovery. This is actually what like one of my lab would look like. I would have a full, well, 3 compute, storage node, I have Ceph, I could have put whatever I want. Controller, I have one, I have MongoDB for Ceilometer. I even have a CMP, I have Scalar running there, so I have a full environment running here. The thing I wanted to show you is that once I'm in fuel, everything is actually, for everybody who used fuel, things are showing up the same way bare metal would show up. The important part of using this tool is the pixie part for discovery. So once you have that, and you know how to set it up, you can actually do VLAN trunking. So you can tag for your tenant isolation, all your private tenant, you can put everything in there. So you can really fake an entire bare metal lab using public cloud resources. And you can save templates, you can put them online. Right now, I'm just fast forwarding because I'm really, really short on time. So I'm just gonna cut it short. I'm gonna wrap up by saying, and I'm gonna skip my last slide because it's I'm just gonna put it there just for the use cases I have for this. Okay, and this is gonna be online, so feel free to see the full uninterrupted video. So I use tools like Véronneau to do like Ceph, Scalar, Intelligent, Calico, OpenControl. There's a repo online for all the blueprints. So Cisco might have something there. You can use it and test SDN on your stack without having to actually purchase anything. So that's the timer. That's 12 minutes. So, and that's the beauty of it, is that it's a community also at the same time. I've created a bunch of blueprints that people are using. People I don't know, people who leave me comments. The whole point of OpenStack is, to be a community and share ideas and resources or tricks that we found, or commit code for the project. This is allowing me, and also the company I work for, not to invest on hardware, but give us solution at a price that makes sense. So when I go to a customer site, I can fire up a blueprint, do a demo, shut it down, and then bring it back up when I need it. So again, I'm gonna be I'm here until Thursday. So if you see me in the hall, you have questions, feel free to ask questions. There's a YouTube channel for CloudOps. You can go there. I've made full videos based on those things also. So feel free to be there and to go there and ask questions. And thank you for being here.